Friends, welcome to my YouTube channel. Today I am going to solve the free convection problem, but with the horizontal plate. Vertical plate already questions we solved. So what is the horizontal plate? How we'll solve? So they given 800 long, 70 mm wide, and maintain a temperature of 140 degrees Celsius. Large tank full of water, 60 degrees Celsius. Determine the heat loss from the plate. So horizontal plate will be there. So full of water will be there. We have to find out heat transfer coefficient of the upper surface and heat transfer coefficient for the lower surface. Then total heat transfer coefficient will be HU plus HL. That is the here difference will be there. And as usual area into delta T, that is called TW plus T infinity. This is called Q. This is called Q. This is nothing but total heat transfer coefficient, HU plus HL. So HU plus HL, upper surface heated, lower surface cooled. Lower surface heated, upper surface cooled. This we have to find out what we explain in the theorem. Again parallelly we will explain that. So how to solve? Now you see, almost steps will be same, little changes will be there, that you have to observe. So okay, so now look here, solutions. What we'll do first, we'll find the as usual film temperature, TF equal to TW surface temperature plus fluid temperature by 2, 140 plus 60 by 2 is coming 100 degrees Celsius. What is this one? Film temperature. So based on the film temperature, we will see the properties of air as HMT data book. So the properties of air, HMT data, density we will see. Density how much? Already data book 961, because this is water. So 961 kg. 961 kg per meter cube. Then kinetic viscosity will be how much? 0.293 into 10 power minus 6 meter square per second. Then Prandtl number will be 1.740. Then thermal conductivity K will be 6804, 0.6804. This unit will be watt meter Kelvin. So this is the thermal conductivity. All the property we taken from the HMT data book with at the temperature 100 degrees Celsius. And also we'll find the beta water at 100 degrees centigrade from the HMT data book. So this will be available in the, if you will see that edition 10, if you will see the edition 10, the page number will be 39. If you go the edition 9, page will be 38. So according to the edition, 1 or 2 page will be vary. So here you are not able to see, but if you see the page number 38, this is the temperature, various temperature, either 5, 10, 20, 30, 40. So we have 100 degree now. What is the beta? 0.076 into 10 to the power minus 3 per degree Kelvin. So this is the given from the HMT data book. So this is the difference between vertical plate and horizontal plate. So beta will not find the 1 by TF. So directly this value from the HMT data book, because here given water, fluid is given water. So at water we saw. Okay, this will see from the HMT data book. So beta I know. Once I know the beta, you go the Grashof number. Grashof number will be the same. What is G beta? Then here LC, characteristic length power 3, characteristic length power 3 into delta T, that is temperature difference, by kinetic viscosity whole square, where LC is equal to, LC nothing but width by 2. So width how much they given? Wide 70 mm. So 0.07 by 2. So this value how much coming? Characteristic LC value is coming 0.07 to 0.035. So 0.035 meter, because you converted into mm the given, so we converted into, so LC we know now. Then we'll substitute all the value, we'll get the Grashof number here, 9.81 into beta 0.76 into 10 power minus 3 then LC will be 0.035 power 3, then 140 minus 60 degree Celsius. All will be in degree Celsius, so right or not a matter. Degree Celsius. So don't write degree Celsius. 140 minus 160, this understable is degree Celsius. Then kinetic viscosity will be 0.293 into 10 power minus 6 unit square. So this way we'll get the GR number. 9.81 G value, beta value 0.76 from the table I taken. Then critical thickness, characteristic length, then 140, 60, then 293. So this value is coming, GR value is coming 0.297 into 10 power 9. GR value is coming 0.297 into 10 power 9. 297 into 10 power 9. Now we'll find the product of the GRPR product. Then we'll see the status of the fluid. So GRPR product na same GR value right here 0.297 into 10 power 9. Then PR value will be 1.740. So this value is coming, GRPR value is coming how much? If we'll see the GRPR value is coming 0.518 into 10 power 9. 10 power 9. So GRPR. Now we'll see here. Two range is there. 0.5 for Nusselt number na, this to this 10 power 6. So definitely this value greater than this value. So 10 into 10 power 11 in between 6 to 11. So now Nusselt number will be 0.15. According to this, got the GRPR value. Our Nusselt number range will be 8 into 10 power 6 in between 10 power 11. So this is the Nusselt number 0.15. GRPR power 0.333. So this range you can write. This range you can write here for understanding. 8 into 10 power 6 less than GRPR less than 10 power 11. So our this value is coming under this GRPR coming under this. So this will be the formula. So 0.15, then GRPR product what will write? 0.518 into 10 power 9, 0.333. So this, if you calculate, this value is coming 0.15, this value is coming 119.66. 119.66. This is coming Nusselt number. Then we'll know the Nusselt number is equal to HU, upper surface heated, HULC by K. HULC by K. So HU will calculate here. So Nusselt number what is 119.66 is equal to HU will get here. LC critical thickness 0.035 by thermal conductivity 0.6804. So this HU will get here. So HU will get here. HU is coming 2326. 2326.19 watt meter square Kelvin. So what we are getting here, HU nothing but heat transfer coefficient for upper surface heated we got. Now again we'll see from the lower surface. So then we'll see the Nusselt number. Which Nusselt number will come here? So if horizontal plate lower surface heated. So this is the Nusselt number. Range will be GRPR range will be coming under this. So for lower surface heated. This you can write upper surface heated here. Upper surface heated. You can write here upper surface heated. Now lower surface heated, what is Nusselt number? Because this single range 10 for 5 to 10 for 11. So our Nusselt number GRPR product is coming 10 for 9. So this directly will write 0.27 GRPR for 0.25. If we substitute this value, same value here 0.518 into 10 power 9, 0.25. So you will get here Nusselt number HU. So this way you will get the Nusselt number here 40.73. 40.73 will get 40.73. This we got the lower surface heated. Lower surface heated. Now Nu is equal to, here you can write HL LC by K. So HL will get from there here HL. So Nu nothing but 40.73 is equal to HL LC, same 0.035. Thermal conductivity K value 0.6804. So here we will get the HL. HL you will get what is 791.7, and this watt meter square Kelvin. So now you see here we got the HU. This is the HU. This is the HL. Then total heat transfer coefficient will substitute here. Direct Q formula will be heat flow rate is equal to HU. Formula I write one time. HU plus HL. Then A TW minus T infinity. So value will write HU how much? 2326.19 plus 791.79. Then area W into L. Area will be somewhere right. Area is equal to W into L. So what is the length into breadth here? W into L 0.70.8. 0.07 into 0.8, because 70 mm 0.07, 800 mm 0.8. This we converted into meter. Then temperature will be 140 minus 60. So this will be the Q value will come. So Q value will come 13.97 kilowatt. 13.97. So this value will write here. Okay, area is equal to, somewhere will write area is equal to W into L. Calculate. So this value is coming 13.97 kilowatt. 13 point. So right answer 13.97 kilowatt. 13.97 kilowatt. So this is the value we are getting the Q. So look here, what is the difference with other problem and this problem? So horizontal plate will be there, means first difference what is beta we have to take from HMT data book, property of the film temperature, how much film temperature will come. So this the at 100 degrees Celsius, water at, this is for Q, this temperature, water at 100 degrees Celsius. We will see the beta value from the HMT data book. We will see from the HMT data book. Then critical thickness width by 2. Then GR will find, then product will find. Then we will see the Nusselt number range. So GRPR range will be belongs to this, means this is the Nusselt number formula. We got the Nusselt number, then HU LC by K. HU means heat transfer coefficient for the upper surface heated. So we got the upper surface heated HU is equal to this value. Now again lower surface heated. This is called lower surface heated. Not able to read na, right nicely little. Lower surface heated. Lower surface heated we find it here. So what is the GRPR range? Same, only single range will be 10 power 5 less than 10 power 11. So in this range, this is the formula for the Nusselt number. Once you don't know the Nusselt number here, we will substitute HL LC by K. HL nothing but what is heat transfer coefficient for lower surface heated. So HL you know. Then what is total heat transfer coefficient? HU plus HL. Then area will nothing but W into L. So W the given void 0.07, L will be 0.8 because we converted into meter, and temperature already 140 minus 60, so getting 13.97 watt. So this way we can solve the horizontal plate problems. Horizontal plate problems little bigger, but 2i thrice if you revise me, this problem also you can solve. So based on this, the convections problem according to university exam, convection problem will ask this range questions will be there. Okay students, watch this video, share this video to your all the friends so they can understand and they can get the benefit. Okay, thank you.